Hey, this is Mr. Kwame. This is day 2 notes, and this is about graphing exponential equations. We already have the table from yesterday. It's the exact same example we started with, and I wrote the multiplier down. It's a 2. And we actually know the y-intercept. We should remember that it's always the ordered pair that has the x value at 0. So in order to graph this, we'll need some scale, and we can kind of dictate how we want to do this ourselves. I'm going to decide to go maybe in the x direction. I'm going to say that maybe every 2 lines is 1 unit. So like this would be -1, this would be -2, so obviously 0. That'll be 1 and 2 and 3. And you can scale this however you want, but the idea is to just fit this all on your graph. I'm going to do a similar scaling for the y-axis, but I'm not going to write it on the y-axis. I'll write it off to the side. So this is, I'm going to go every 2 units is 1. So that would be 1, 2, 3. And then plot the points. So -2 is at a 1/4. So it's pretty low. It's between like, it's not even at a half, it's 1/4, so it's a 1/4. And then -1, you're at a half. It'll be right there. 0 is at 1. And then just continue on. So 1, 2, 2, 4. And then 3, 8. And so this is a nice smooth curve. Goes up like this. And it as you can see, like each next unit gains quite a bit. Like the distance from 0 to 1 in the x direction, is not it doesn't go up that high, but then from 1 to 2 jumps up much higher, and then from 2 to 3 jumps up even higher, because it's exponential. So then the other important part about this, we graphed it, and really just kind of making a scale is the difficult part. What we need to know about domain and range. And what domain refers to is what x values you can potentially substitute in for x. Like, is there any math rules that are stopping you from plugging in some numbers for x? And in this case, no. We don't break any math rules by plugging in, negative numbers or 0 or positive numbers. We actually know how to handle it, like we do 2 to the, -8. We know that is. It just ends up being a fraction, 1 over 2 to the 8. Small number, but that's what it is. And in fact, like if you plugged in like, some number, like let's say -100 for x, it'd be 2 to the -100. And that's really gross. It's going to be some gross number. You get 1 over 2 to the 100 power, and, really 2 to the 100 is going to be some large number just on the bottom. But if it's on the bottom of a fraction, it's a really large number. That means the whole number, this right here, is really close to 0. It's not 0, it's some fraction. But given that, like if you plug in any negative number, you'll see that like you'll get some gross fraction, but it's still going to be a fraction. It's not going to be 0, maybe really small. But in any event, there's no number you can't plug in for x. Like you can plug in anything you want, and it doesn't matter. You're going to get some number. So the domain is the set of all real numbers, and that's the fancy little sign for it. It just means that you can plug in anything you want, and it's fine. The range, however, is a little bit different. The range means what can you get out? Like if you plug in anything for x, what can you get out for y? So you'll notice that we start plugging in some really negative numbers. Like we plugged in like -100. We got a really small number, like 2 to the 100. I don't even know what that is. 1 divided by 2 to some really large number is going to be very small. But what you notice is you never get a negative number for y. You can plug in anything you want for x, but you're not getting a negative for y. So like, let's just try it out. Y equals 2 to the, -7. Well, we know that that's 1 over 2 to the 7. and 2 to the 7th is 128, so 1 over 128. That's a really small number, but it's not 0. So you could get even crazier, like we did, 2 to the negative 100, but it's still not going to be 0. It's going to be some fraction. So in essence, your range is not going to ever be negative. I mean, obviously we know that if we plugged in, 2 to the 16th, that's going to be a very large number, obviously not negative. So your range is like the set of all real numbers as well, but only positive ones. And again, so I filled out everything that we had from yesterday. This is the exact same example. It's 0.25 to the x. The multiplier was 0.25, or fourth. And we could scale our graph to graph it. In the scale, I'm just going to keep everything kind of as it is. I still did every 2 lines in the x direction is 1 unit. And then I'll go every line in the y direction. So this would be 1, 2, 3, 4. And then I'll skip a couple here. So you see, we plot these points. So when I plotted these points, you kind of realize really fast that, like, man, this graph is like, it goes down. Well, let's try it again. The graph, like, goes down very fast. And the thing is here, sorry about this nonsense. The thing is here is that it goes down very fast, and like, even when you're at 1 on the x, you're at a quarter. And then when you're at 2, you're at 1/16th and 1/64th. Those are really small numbers, but I mean, even if you keep on going, you keep on plugging in, like if you plug in 4 here, you're gonna end up at 1/4 to the 4th is 1 over 256. That's a small number, but it's still not 0. So that's important. The domain, again, is just meaning that, like, is there any x values you can't plug in? And no, it doesn't matter. We can plug in any negative number, any positive number, and there's no rules being broken. We can plug in whenever we want. So this is the set of all real numbers. But in the range is, we're thinking, what numbers can we get out? When we plug in any number for x, what number can we get out for y? And so if you plug in any negative number, you know that the worst that's going to happen is you're going to get a really small number. Any number you plug in, like that's larger, like the 5th power, the 6th power, is just going to make some really small number, like a fraction with a large number on the bottom, meaning the overall value is really small. Or you could plug in a negative number, but we already know that, like, you plug in -2, we got 16. Plug in -3, 1/4 to the -3. That's going to flip it and go 4 over 1. And that's like 64. So you plug in a really negative number, you're going to get y is going to be really large. You plug in a really high positive number, and y is going to be really small. But it's never going to be negative. So that's the key. Your range is actually only positive numbers. Again, you don't get any negative numbers. Like, this graph will never cross below the x-axis. Y will never be negative. Alright, last example. So I filled in everything I know. This is from yesterday. We know the multiplier is 3. We know the y-intercept is 2 when we have the table filled in. We can make our scale however we want it, but ultimately our largest number is 54. That's pretty big. Alright, on this scale I'm going to go by 3s. So this will be like 3, 6, 9, 12, 15, 18, 21, 24, and so on. So when you plot your points, you get them all there and try a nice little curve, and it goes up really fast. Nice arrow. And so again, when you think about your domain, there's nothing you can't plug in for x. I mean, you're going to get either a fraction or a really large number, so you can plug in anything. It's all real numbers. And again, that's the sign for all real numbers. And then your range again, you can get any answer, but it will never be negative, because any negative number you plug in for x is just going to make your y value smaller. Like if you plugged in 2 times 3 to the, if you plugged in like negative even 4, you'll get 2, and then 3 to the negative 4 as a drop down. It's be a fraction. It would be 3 to the 4th on bottom, which is 2 over 81. So still a positive number. It just happens to be a small fraction. You plug in a larger negative number for x, it's still just going to be some large number on the bottom of a fraction, meaning that your total answer is a smaller number. So it's just a fraction. So you'll never end up with a negative number. Your range is then still all real numbers, but only the positive real numbers. So that's what that plus sign means.